1 terabit per second. That single number is making governments, tech companies, and researchers around the world stop and pay attention. Imagine downloading around 20 full-length HD movies in less than 1 second. Not in 1 minute, not even in 10 seconds, but before you can blink. That is the incredible wireless speed Chinese researchers recently demonstrated in a laboratory. And it is being called one of the biggest steps toward the future of communication. Even today's fastest 5G networks would need nearly 2 minutes to move the same amount of data. So, how did researchers suddenly achieve a speed that seems almost impossible? And more importantly, what could it mean for all of us? The answer goes far beyond watching videos faster or downloading games in an instant. This breakthrough could completely change how self-driving cars communicate, how factories operate, how doctors perform remote surgery, and even how artificial intelligence systems work together in real time. In other words, this is not simply about making the internet faster. It is about creating an entirely new kind of wireless network designed for a world where machines, robots, sensors, and AI constantly exchange information without delays. Before we dive into this incredible story, take a second to hit the like button if you enjoy learning about the future of technology. These videos take many hours of research to create, and your support really helps the channel grow. Also, subscribe and turn on notifications, because later in this video, we'll reveal how this technology was tested outside the laboratory, in a real city during one of the most difficult weather conditions imaginable. That experiment changed the minds of many experts who were originally skeptical. But first, we need to understand why 5G, despite being so advanced, is already reaching its limits. When 5G first arrived, it completely transformed wireless communication. Compared to 4G, it offered dramatically higher speeds, lower delays, and the ability to connect far more devices at once. It wasn't just another upgrade. It became the foundation for many of the technologies we now rely on every single day. The secret behind 5G is surprisingly simple. It uses much shorter radio waves than previous generations. These shorter waves can carry much more information, allowing data to move much faster. The downside is that they cannot travel very far. Instead of relying on a few massive cell towers spread across cities, 5G depends on thousands of smaller transmitters placed much closer together. Think of older wireless networks as giant floodlights lighting an entire football stadium. They covered a huge area, but they weren't very precise. Now imagine replacing those floodlights with thousands of tiny lights spread throughout every section of the stadium. Suddenly, the light becomes brighter, more focused, and reaches exactly where it is needed. That is essentially how 5G works. This new design opened the door to applications that once sounded like science fiction. Hospitals can now stream high-quality medical images between specialists almost instantly. Factories can control robotic machines with almost no noticeable delay. Shipping ports can track thousands of containers wirelessly without miles of cables running across the ground. Farmers can monitor soil moisture through sensors spread across enormous fields, helping them save water while increasing crop production. The growth has been remarkable. By 2023, more than 1.5 billion active 5G connections existed around the world. That is roughly equal to the entire population of India carrying a 5G-enabled device at the same time. Few technologies in history have spread that quickly. Looking at those numbers, you might wonder why researchers are already working on something even faster. After all, 5G already feels incredibly powerful. The truth is, 5G isn't failing. In fact, it continues to perform exactly as engineers designed it to. The challenge is that our world is changing much faster than anyone expected. Today's wireless networks mainly connect people. We stream videos, make video calls, browse websites, and send messages. But tomorrow's networks will increasingly connect machines instead of humans. Picture a busy intersection filled with self-driving cars. Every vehicle must instantly share its location, speed, and direction with every other vehicle nearby. Even a tiny communication delay could become dangerous. Or imagine a surgeon operating a robotic arm from hundreds of miles away. A delay so small that you would never notice it while watching YouTube could feel like an eternity during delicate surgery. Engineers call this future the Internet of Intelligence. instead of billions of people using smartphones. Billions of intelligent devices will constantly exchange information with each other. Artificial intelligence systems, industrial robots, autonomous vehicles, drones, sensors, and smart infrastructure will all need to communicate at the same time, every second of every day. This creates a completely different challenge than streaming movies or scrolling through social media. To understand why, imagine the difference between watching your favorite show and driving a car through a crowded city. If your movie pauses for half a second, it is slightly annoying, but nothing serious happens. If a self-driving car reacts half a second too late after detecting a child crossing the street, the outcome could be completely different. That is why engineers pay so much attention to something called latency, or communication delay. Under ideal conditions, 5G can achieve delays of around 4 milliseconds, which is incredibly fast. For human users, that delay is almost impossible to notice. But for machines making life or death decisions thousands of times every second, engineers want communication that is even faster and even more reliable. Another challenge is capacity. A single 5G tower can reliably support around 1,000 connected devices before performance starts to slow. That sounds impressive, until you imagine a packed stadium with 60,000 smartphones, cameras, sensors, drones, and smart devices all trying to connect at once. Suddenly, even 5G begins reaching its limits. Instead of pushing 5G further, researchers looked toward an unexplored part of the radio spectrum called terahertz frequencies. Think of today's 5G network as a crowded 6-lane highway. Terahertz frequencies are like discovering a brand new 20-lane highway with almost no traffic. The potential is enormous, but there was one major problem. Terahertz waves are extremely sensitive to moisture in the air. Even normal humidity can weaken the signal within just a few feet. For years, research teams in China, the United States, South Korea, Japan, and Europe all faced the same challenge. Inside dry laboratories, the technology worked incredibly well. Outside, the signal quickly fell apart. The breakthrough came with a new antenna array built from thousands of microscopic elements on a chip about the size of a postage stamp. Instead of sending one fixed signal, the antenna constantly adjusts itself thousands of times every second to compensate for changing air conditions. That allowed researchers to maintain a stable connection across hundreds of feet, roughly the length of a football field, instead of losing the signal after only a few feet. Even so, there is still work to do. The technology has not yet been proven in every climate, and today's smartphones and computers are not powerful enough to fully use 1 terabit per second speeds. But this breakthrough shows that terahertz communication is moving beyond the laboratory and could become the foundation of future 6G networks. In 2024, researchers launched an experimental 6G pilot zone across roughly 40 city blocks in Shenzhen, China. They deliberately chose a busy manufacturing district packed with steel structures, concrete buildings, and heavy machinery, an environment where weak wireless signals would normally struggle. The results surprised even experienced engineers. The network reached sustained speeds of around 860 gigabits per second, coming remarkably close to the 1 terabit per second lab record. Even more impressive, the tests were conducted during Shenzhen's humid summer, where humidity often exceeds 80%. Moisture had long been one of the biggest obstacles for terahertz communication, yet the new system continued to perform reliably. Researchers also found they didn't need to build an entirely new network. Many of the experimental antennas were mounted directly onto existing 5G lamp post infrastructure, making future deployment faster and far less expensive. The successful trials quickly caught the attention of the global telecom industry. Companies and research teams across China, the United States, Europe, Japan, and South Korea have accelerated their own 6G research, with more than 140 international patent families now covering similar antenna technologies. However, this doesn't mean 6G is arriving tomorrow. Industry experts expect official 6G standards around 2028, with commercial networks likely appearing closer to 2030. There are still manufacturing challenges to overcome before these advanced chips can be produced on a massive scale. Even so, this breakthrough marks a major milestone. Just as 4G made smartphones mainstream and 5G connected billions of devices, 6G could power the next generation of AI, autonomous vehicles, smart factories, and remote healthcare. What looks like an experimental technology today could become an everyday part of our lives within the next decade.